Hi everyone, my name is Yizu and I'll be going over the essential topics and grid questions in Calculus Chapter 3 of the course revision sheet. This is for the grade 12 final exam. So first up we have absolute maximum and absolute minimum. When looking for them we have to spot the critical points. Critical points are when y prime is either 0 or undefined. So to find the critical points, we derive the equation and solve for y prime equals 0. In doing so, we can find the x coordinates, then presumably find the y coordinates from the original equation. The resulting coordinates can either be a maximum or a minimum. So here we have grid number 1. We're given f of x equals 3x cubed plus 9x squared, and x belongs to the closed interval minus 1 to 2. So they're asking for absolute maximum minus absolute minimum. Like, what's the number of it? So once you have these type of questions, you derive the equation. So f prime of x gives 9x squared plus 18x. Make f prime of x 0. You get 0 equals 9x squared plus 18x. Solve for x. You'll get x equals 0 and x equals minus 2. There are your critical points. Substitute the points in f to find absolute max and min. We substitute these points along with the endpoints and the start points of the closed interval of x, which is minus 2 and 1. So we have f of minus 2 gives 12, f of 0 gives 0, and f of 1 gives 12 again. And make sure to substitute these numbers in the f of x, not f prime of x. Many people get confused by that. Just remember it. So absolute maximum is 12 and absolute minimum is 0. Therefore, 12 minus 0 gives you 12. That's your answer. Next, we have Rolle's theorem. Rolle's theorem requires these three conditions to be met before we can apply it. So the conditions are f of a equals f of b. The y values have to be equal. It doesn't have to be 0. In the course revision sheet, they'll say it's equal to 0, but it doesn't have to be. The second stuff we have to make sure it's true is f of x is continuous between the closed interval a to b. F of x is differentiable between the open interval a to b. If these three conditions are all met, then there exists at least one point c which belongs to a to b where f prime of c is 0. So you can see over here the f of a equals f of b and a to b. You see f prime of 0 means the slope is 0, which is a horizontal line. There's 2 points of c in this curve. Now we have grid number 2. Given f of x is 4 sine x over 4 and over the closed interval 0 to k pi, what's the smallest value of k for which the function has at least one point c in the given interval where f prime of c equals 0? So once you see f prime of c equals 0, we have to recall Rolle's theorem, all the conditions you have to be met. So this f prime of c equals 0 is the last thing. So it means if it exists already, it means that the first three conditions must be true and must also exist. So f of 0 must be equal to f of k pi for f prime of c equals 0 to exist. Same with f of x to be continuous between the closed interval, and same with f of x to be differentiable between the open interval. So we already know it's continuous, we already know it's differentiable because it's a sine function, but we just need to find k that will allow this f prime of c equals 0 to exist. So this is the important equation. F of 0 equals f of k pi. Then substitute in the original equation. 4 sine 0 equals 4 sine k pi over 4. You can simplify more, which gives you sine 0 equals sine k pi over 4. Then from our previous years of trigonometry, we learned that for sine, there's two ways to solve for an angle. Either theta equals alpha plus 2n pi, or because we have to use both, and theta equals pi minus alpha plus 2n pi. I like to use theta as the k pi over 4, the one with the variables, because it's more direct. Like at the end you'll have k equals something. So on our left equation, on our first equation, substitute theta as k pi over 4 and alpha as 0. We're going to have this equation and we'll get k as 8n. Do the same for the equation on the right. You'll get k equals 4 plus 8n. So since n is an integer, we can pick any value, negative or positive. or 0. But since the smallest value, they're asking for the smallest positive value, means we want like something greater than 0, then we don't substitute n with any negative values, because it would obviously give a negative number, which will not satisfy the question. So if n equals 0, k has the values of 0 and 4 from the equations. If n equals 1, k has the values of 8 and 12. Since the positive values are always getting bigger, we can conclude that k equals 4 is the smallest positive value in which f prime of c equals 0. We don't include 0 because it's already in the interval. So we'll just include the closest next value, because in this case they're asking for the smallest, so which is 4. So k, which is 4 pi, so k will be 4. 3. Consider the function f of x equals minus 2x squared plus 14x in interval, closed interval 0 to k. This is just like the last question, but it's much more simpler. So apply all these conditions, and then we'll end up getting f of 0 equals f of k. And substitute 0 and k in the original equation, you get 0 equals minus 2k squared plus 14k. Solve for k, you'll get k equals 0 and k equals 7. 0 is already in the interval, just like the previous question, so we pick the other smallest value. Since the other one is just 7, the answer is just 7, k equals 7. Mean value theorem. It's really similar to the Rolle's theorem, but it doesn't have the condition that f of a equal to f of b. It just has a random value for f of a and f of b. So f of x is continuous between the closed interval a to b, and f of x is differentiable between the open interval a to b. Like if these are met, then there exists at least one point c which belongs between a to b, where f prime of c is f of b minus f of a over b minus a, which is just the slope of this secant line. You see y2 minus y1 over x2 minus x1. And then they're just saying that there exists one point c where the slope of the secant line is equal to this slope at point c. Notice at point c, there's the tangent line, the slope of the tangent line is equal to the slope of the secant line. Number 4. Given f of x equals 2 tan x over 2, which are true? 1. F of x is continuous over the interval 0 to pi. How do you know if it's continuous from 0 to pi? My strategy is to substitute values. So I normally substitute 0, pi over 2, and pi. And by chance, I got, like, if I substitute pi as first, you get undefined. So, like, it takes trial and error, but you can also know it by understanding from the tan x equation. We have tan x, yeah, it's undefined. Like for the pi and the values are substituted. Though if you get undefined, means it's not continuous. So let's look at the tan x equation. We have x, when x is pi over 2 or 3 pi over 2, the function is undefined or discontinuous. That's for tan x. But since we have tan x over 2, we multiply 2 to each x value. Therefore, we get pi and 3 pi. Notice how they're like linked, but just by a factor of 2. So 1, it's continuous over the open interval 0 to pi. Since it's open interval, we're not including the values 0 and pi. So we don't care if it's discontinuous at 0 or pi. We just care about if it's continuous between them. If we substitute pi over 2 in the equation, we'll get 2 tan pi over 4, which is 1, I think. So if it's 1, then it's defined, so it's continuous. Therefore, 1 is true. 2, it's differentiable over the interval 0 to pi. We can derive the equation and we get secant squared x over 2. We know that secant x over 2 is the same as 1 over cosine x over 2, yeah? So f of x is not differentiable when x is pi or 3 pi, because if you substitute x as pi in this 1 over cosine pi over 2, x over 2, yeah, you'll get 1 over 0, which gives you undefined. So it's not differentiable at pi. But since it's an open interval, we don't care about the 0 and pi. We just care about what's between them. If we substitute pi over 2, we get cosine pi over 4, which gives you like 1 over cosine pi over 4, which gives you a definite value, so it's differentiable. So 2 is true. 3. It is differentiable at x equals 0. Just substitute in this equation secant squared x over 2. If you substitute 0, you'll get 1. Yeah, you get 1. So it's a definite value, so hence differentiable. 4. It is continuous over the closed interval 0 to pi. Now we have closed interval. We have to make sure that it is right continuous at 0 and left continuous at pi. We already showed that it's discontinuous at x equals pi. Like, if it's discontinuous, it's not right nor left continuous. I mean, it could be, but like in this case, it just approaches to infinity, so it's just undefined. Therefore, 4 is wrong. And 5. There exists at least one value c between 0 to pi such that f prime of c is this. This looks really similar to the mean value theorem, which states that in order for this to exist, we have to have two conditions. And one of the conditions is f of x is continuous over the closed interval a to b, which is 0 to pi in this case. We prove that it's not continuous over the closed interval, therefore 5 is false. We can't prove 5. The answer is 1, 2, 3. Now we have finding asymptotes in fractions. So over here you have a fraction with the biggest power x is a for the numerator and the biggest power on x is b for the denominator. If a is less than b, then y is the horizontal asymptote. Just understand or memorize it. So in the example will be really fast. If a is equal to 0, then the horizontal asymptote will be the division of the coefficient of the x's with greatest power. So like if you have let's say 2x squared over 3x squared, so the horizontal asymptote, like since these two are equal, yeah, we can directly cancel them. The horizontal asymptote will be 2 over 3. So y equals 2 over 3 is your horizontal asymptote. 4. If a is, the next one, if a is greater than b, then there is an oblique asymptote. It won't come in the exam, don't worry about it too much. Notice how like all three of them, yeah, they're really similar to the limits as x approaches to infinity for fractions. And to find vertical asymptotes, just equate the denominator to 0. The values of x will be the vertical asymptotes. Now, drawing curves. Curves are like, you have to follow these 6 steps to make sure that you will get a full mark on the curve, on your graph, So, the graphing part is obviously the most important, but these 5 steps are what makes it to number 6. So first, state the domain. So basically you're just stating the domain of x, which belongs to what? Either real numbers or like let's say for y equals 1 over x. Its domain is real numbers minus the x is when x is 0, because if it is 0 you get y is undefined or y is infinity. So over here they said state vertical asymptotes. So we can say that x equals 0 is a vertical asymptote from this 0 over here. 2. Check the behavior as x approaches to plus or minus infinity. So you're going to write as x approaches to, let's say, plus infinity first. We're still using this equation. We get 1 over infinity, which is 0. And then we can state that y equals 0 is our horizontal asymptote, because as x approaches to an infinite value, y approaches to a definite value, which is 0. So this is your horizontal asymptote. In addition to that, you have to state the range. So range would be just real numbers in this case, I guess, because actually for range you just have to look from the equation. Notice how if you substitute from plus infinity, x is plus infinity, you get 0. And if you substitute minus infinity, you get 0 also. So the smallest value you can get is 0. So range would be between 0. It's parenthesis, not brackets, because it's not included. As it's an asymptote. 0 till r, because like it can approach to infinity for y. Like y can go as high as it can. It can't go below the 0 though, so 0 to r. Or 0 to infinity, in fact. Never mind. 0 to infinity, I apologize for that. Plus infinity to be exact. That's your range. Next, solve for y prime to find max or min. And you can also find y double prime equals 0 to find concavities, but it's not necessarily needed, because y double prime can be really complicated and you might just get more confused. But you won't lose marks for like not including it. Your marks depend on your graph at the end. For draw a table of variation, this is the x, and then you have y prime, and then y, and then you have all the values, you know. Look at the course revision sheet, they have a better table. 5. Find the x and y intercept. This is like a step that everyone skips. Don't skip this step. You lose like marks just for skipping these easy parts. So once you find it, you'll get the marks. It's like just substitute values, not that hard. Just don't forget it. Then 6, you have to graph. On your graph, make sure you show the intercepts. Like if you're gonna draw a function where the x-intercept is 1, make sure you include that it intersects 1. It has to go through 1. It can't just be a random one like this. It has to go through 1. And asymptote with dotted line. So like, let's say this is 2, okay? You have a horizontal asymptote, y equals 2. You're gonna draw a horizontal like that, and then say y equals 2 over here. That's your horizontal asymptote. And when you draw it, make sure it doesn't intersect this dotted line. Next, we have grid questions from another section. When we're given x equals radical t and y equals t squared. So they're asking for this d squared y over dx squared, which is just y double prime, equals kt. We're looking for k. So given these x and y, we can derive them in terms of t. So dx by dt gives 1 over 2 radical t. dy by dt gives 2t. So we could do dy by dx gives dy by dt over dx by dt. Just memorize this formula. It's much more simpler if you just memorize it. Equals, so we have these two, just substitute, you get 4t to the power of 3 over 2 y, which is equal to y prime. I can derive the y prime in terms of t, because t is the variable. And dy prime by dt gives you 6 radical t. And then for our the y double prime, it's basically just dy prime over dt over dx by dt. Memorize this one also. You have all these values, you get 12t. 12 is the whole number to be determined. And last question, we have 3 different functions and we're looking for the graphs. So let's start with f. X equals 0.75t and y is radical t. We can substitute t, we can isolate the t in the x equation and get t equals x over 0.75. And substitute it in the y equation, we'll get y equals radical x over 0.75. So we know all equations with y equals radical x, the curve will look like something like I. Just memorize it's I. Radical x, like not I, just radical x has the shape of I. This, you see how it's going like this concavity is downwards. So this is a graph of radical x. So the 1 or 2 we got as I, so 1 is true. Then g, for function g, x is t squared and y is t to the power of 9. For this case, we can't use the substituting t because we're going to have a really weird function and we don't know the shape of the curve. So it will be weird to be solving it that way, or like really difficult. So we'll find t greater than 0 and t less than 0. Like we're going to find the x and y values when t is greater than 0 and t is less than 0. For g, when t is greater than 0, we get x is greater than 0 and y is less than 0. And when t is less than 0, you get x is greater than 0, y is less than 0. So we know, so in the function, it must contain something with x is greater than 0 and y is greater than 0. So like when x is positive, y should also be positive. Like let's see number 3. X is positive, y is positive. That like supports this statement. And then we have when x is greater than 0, y is less than 0. So when x is positive, y is negative. Notice how it supports both statements, so 3 is correct. And in your answer choice, you're going to put 6. And h, x is minus t to the power 5 and y is t. Just do the same step as what we do with g. You'll get for t is greater than 0, x is less than 0, y is greater than 0. For t is greater than 0, x is greater than 0, y is less than 0. So there must be a curve or like a part of the function where x is less than 0, y is greater than 0. 1, 2, and 3 are all cancelled because there is no values on the left side, which is x less than 0. 4 and 5, when x is less than 0, y is greater than 0. It's true, so we'll keep 4 and 5. And then we have t is less than 0, we have x is greater than 0 and y is less than 0. So when x is positive, y is negative. 4 is wrong and 5 shows the correct one. So the answer of it will be 3. The answer is 1, 3, 5. Thank you so much for listening to this lesson. If you have any other videos you have to watch them now. And good luck in your final exams.